Hello everyone, welcome back to WebDev Solutions. Today in this video, we'll be learning about VRF. So first of all, let us know what we'll be learning today. Okay, first of all, we'll be seeing what exactly is VRF, and we'll see some use cases of VRF, like what's the use case and how exactly it's being used and where it's being used. After that, we will see the core architecture in the sense how VRF exactly works. And after that, we will implement VRF in our Solidity game. So if you're excited, let's get started. So first of all, let us see what is VRF. Okay. So what is VRF? Verifiable random. So what is VRF? It's a verifiable random number generator that enables smart contracts to access random values without compromising security or usability. This is as simple as it. Okay. You can just think of it as a random number generator that enables smart contract to access random numbers. So you might ask like why randomness is a big deal in Solidity smart contract. You can't get a because like you can't get a random number in Solidity. You may say like we can use block difficulty and block numbers and all. All those things can be predicted and are not random. Okay, you know that like if current block number is 101, the next block number will be 102. You can't like it's not a random number over there. Okay, you can't have difficulty as well because like the miners can modify it to their favor. Okay, you can think of it like that. Okay, so now let us see. As you got to know, like it's just a random number provided by Chainlink. Okay, it's a secure, fully secure. You can look at their documentations like how exactly the security is being implemented. But for now, we as developers, we just like don't want to go too like deep into security concerns. But it's fully secure. You can look at it in their documentations. Okay. So now let us know, like let us see like what all the use cases of VRF. Okay, so first use case is like if it's like if you are performing a lottery contest or so, like there will be a random picking of the winner. There you can use this, or if you are providing giveaway for your users or your community, like the tokens or whatever, like you can use a random number generator to like randomly pick some numbers, and you can have some like in-game assets like if you are like randomly having some in-game assets and all those stuff, you can use it in there as well. In NFTs, if you want to determine randomly, like if there is anything in terms of NFTs randomness, you can use VRF in there as well. Okay, you can look at their like website, like where they provide complete details of even some of the they provide details of some of the projects that are implementing VRF for their products. You can look at it there as well. Like I'll provide the link in the description. You can just click and watch over there. Okay. So for now, we just have to know like what is VRF and what are the use cases. This is basic use cases. There are like you can do more complex things as well. But the most common use cases are random picking of users or giveaway things or NFTs or in gamings and even supply chain management as well. You can like you can ask GPT or so this is how it VRF works. VRF is being used by most of the applications. So the second part, how VRF exactly works. I hope you all got what exactly is VRF. If you have any questions, let me know in the comments. Okay. Okay. So now let us see how exactly VRF works. Okay. So let us see step by step how VRF exactly works. So first of all, you will have to create a subscription for your contract. Okay. First of all, you will create a smart contract that implements the structure which is required for VRF. Okay. We will see like in practically we will code our own smart contracts to create a game using Solidity. Okay. So first of all, we will have to deploy our contracts, which is implemented using like you just have to create contract and deploy it to any chain. After that, you will have to go to subscription manager, which is here. All the links which I am using here will be in the description. You can just click over there. You have to create a subscription. Okay. After that, you will have to pay some like pay in the sense fund your subscription with your link tokens. Like this is the same subscription as your TV subscription or mobile recharge kind of thing. You will have to pay it and it will be consuming in our contract. Okay. We will see there later. Okay. If you need contacts like a Chainlink tokens, you can get it here using faucets.chain.link. This link will also be in the description. And after that, what it does is first of all, we'll have to create subscription. And once subscription is created, VRF coordinator will like create our subscription. Like this is the user interface. VRF coordinator will store our subscription details. Okay. And after that, we will be funding our subscription with some gas tokens. Gas tokens in the sense link tokens. Okay. So after once we have funded it, we will register our contract. Registering our contract means we will provide our contract address to our subscription, saying that this contract can use verifiable random function in their contract. In the sense, they can request random numbers in their contract. This is what it specifies. Okay, we just have to provide our address, and after that, like it will know like if the request is coming from this contract which we have provided, it will look into our subscription and look at if if our subscription is being like funded with the link tokens and all. If every criteria is matched, in the sense everything work correctly and verified, after that our contract will get some random numbers. Okay, we'll see how it's being worked. But first of all, you will have to create subscription for that. Okay, this is subscription process. Nothing but like you just have to create a subscription, fund it, add a consumer. That's all. Okay. So now let us see how we get a random number. Okay. So let us just come a bit down. Yeah. So first of all, this is user as we all, and this is our consuming contract. Consuming contract is the one which we deploy. It can be any chain, like they are provide multiple chains as well. We'll in this case we'll deploy to Sepola chain in this video. Okay. So first of all, we will create consuming contract with the details of VRF coordinator and all, because like we have to provide details of VRF coordinator so that we are getting like getting the random numbers from this coordinator. So what we'll do is we will call the VRF coordinator. This will be a contract, okay? We will call a function of VRF coordinator. It will be like request random numbers or request random words. That kind of function will be there. We will call that function with specific parameters. We will say what are the parameters over there in our Solidity, okay? What it does is it just emits an event. So once it emits an event, there is a VRF. Okay, I'll just use my laser pointer. Okay, here as you can see, there is a VRF service which constantly listens to the events emitted by coordinator. Okay, once we like request a random words to VRF coordinator, it emits an event with the data required. This VRF service constantly listens to this events. Okay, once this event listens to an event, it waits for certain block confirmations. Okay, like block confirmations will be specified in our parameters which we pass while calling VRF coordinator. Okay, so once we pass and everything happens, like our is the part is here, and I mean event emits happens, we will let us say we'll specify block confirmations of 3. It will wait for 3 block confirmations over here. After 3 blocks, this will already be like generating random numbers. Like they have their own decentralized networks which are used to like decentralized oracle networks which are used to like generate random numbers. Okay, we're going to verify this. Look at this at now. Okay, so there are like decentralizedly like they will create a random number which can be verified as well. Okay, you don't have to worry much over here. So this is a very like random number generator. Once this generates random number, this waits for certain blocks which is specified in our parameter. Okay. So once that certain block confirmations are done as we have specified, we will like get to know more about in our code. There will get to know in detail like how it exactly works. After we are like waiting for certain blocks which we specify, after that block confirmations, it will call VRF coordinator saying that call this consuming contract with this random number words. Okay, it will like verification and everything happens here in VRF service as well. Okay, you can like what do you call like track your random words in the way, but like whether your random number request is fulfilled or not in your subscription. Okay, so once it's like calls VRF coordinator, VRF coordinator calls our contract with a function, or calls our contracts function with a random words which is provided by VRF service. Okay, this is how it exactly works. So first of all, you will create a subscription, add your like you will fund it and add your smart contract as a consumer, and your consumer will call coordinator, which will event emit an event. VRF service will listen to this event. In the sense, it will constantly look to this contract and see if there is any events of specific to requesting random numbers. And after that, it will wait for certain block confirmations which we specify. Once the confirmations are done, it will call VRF coordinator with the random words, whichever consuming contract will get from a function. Okay, we will exactly see how exactly it works. Okay, so first of all, we will move over to our Remix IDE. If you don't know what Remix IDE is, it's an IDE just as your Visual Studio Code, but it is like specifically made to create contracts and creating contracts and deploying to contracts on chain. Okay, so this is how it works. Like you just have to come to remix.ethereum.org. The link will be there as well, like in the description as well. Okay. So first of all, we will create a new contract. So you might be wondering what will the game which we'll be creating in this video. So in this video, we will create a game which you all probably know from your childhood itself. Okay. Guess the thing. I'll just give you 5 seconds. Guess the thing. The clue is already here. Okay, so today we are gonna create a rock, paper, and scissors. Even in English, you can say a stone, paper, scissors as well. We are gonna create a rock, paper, scissors game. Okay. So first of all, we will implement random functions here to we will play with computer. Okay, computer in the sense we will see how exactly it works. First of all, let's start coding. So we will specify the license identifier. For this, we will use MIT license and we'll use pragma solidity 0.8.19. So yeah, so above versions of 0.8.19, we will use it here. We will create a contract that is which name is rock, paper, and scissors, which should implement from VRF code. Like we should implement VRF coordinator in order to request the random numbers. For that, we will import Chainlink contracts over here. Okay, these two lines of code, right? It will be there in the comment section. I'll pin it in the comment section. You just have to go there and copy these two lines of code. Okay, nothing much. You just have to copy it here and paste it here. So this should inherit VRF coordinator. Okay, so we will look into what VRF coordinator exactly does. This is just a interface, and this is just we are using it in the later. First of all, we'll have to implement consumer. Okay, VRF consumer base v2. Where is it? Abstract. Yeah, here it is. We have to implement it in our rock paper scissors contract, and we will implement it, and we'll have to create a constructor. Okay, constructor. We will pass the VRF coordinator address. Okay, address VRF coordinator. So this address we will pass it to our constructor of this contract which we are implementing, and to this we will pass VRF coordinator. So first is VRF coordinator which will pass here. Okay, this is what the constructor takes, and after that we will have to store VRF coordinator interface as well. Like we will use this interface. This will be, let's make it public. Okay, public, and this is coordinator. Okay, the coordinator will be our contract. In the sense, we'll use your interface to assign it. Okay, we will use this and our address VRF coordinator. So we will store our coordinator here, and we'll pass our coordinator address to the consumer base. After that, we will implement the functions which have to be implemented because we are inheriting consumer base. Okay, so let us see what are the functions which we have to implement. Okay, first of all, we will go to VRF consumer v2. You just have to control click this thing. It will redirect to this contract over here. So first of all, let us see what we'll have to implement. First of all, we will have to implement this fulfill random words function. So we will copy it. Okay, we will copy it here and paste it here, and this will be public, and we will just add here. We will not implement anything over here for now at the least. We'll have to override this. Override. And what else? Okay, fulfill random words. Okay, we will implement the body of this later. Okay, first of all, let us have some things. Okay, like first of all, we will have to have subscription ID. Okay, so we will have to like manage our subscription, right? Like we will have to provide our subscription ID to our VRF coordinator so that it looks into that specific subscription and looks at whether it is like funded or not, all those stuff. We will say public constant constant and subscription ID. So we will get this subscription ID from subscription ID in the sense subscription number. Okay, we will get this subscription number from in our constructor and we will store it here. Okay, so we will just move this upwards. So this should not be a constant, otherwise we can't initialize it. Okay, so we will have three moves in the sense like whether either it can be a stone, either it can be paper, either it can be scissor, right? Like the here we will first make our move in the sense either we will provide stone, paper or scissor or rock, paper or scissor, and we will get a random function and we will take randomly a number which is provided by VRF and compare it, like we will match it with either rock, paper or scissor and see like if we provide rock, like if our move is rock and the computer's move, in this case VRF coordinator move is paper, the VRF coordinator will win, of course. All right, okay. So this is how it exactly works. Like we'll see how exactly it works in the implementation in just below. Okay, just we will create a event 256 public constant and this will be rock. We will use a 0 for representing rock and event 256 public constant, and we will have another for paper, another for scissor. Okay, paper equals 1. We will use paper to represent 1, and after that we will use scissor, SCISSOR. Hopefully scissor is, yeah, scissor is correct. So we will use 2 to represent scissor. Okay, so we will store three more things. First of all, we will store in 256 public user move. User move, first of all, will not initialize it. User move, and after that we will have computers move e, and after that we will have winner. We will have string. Okay, string public winner. Okay, so first of all, like we will have user move. First of all, we will be making a move in the sense we will say like whether we are specifying rock, paper or scissors. After that we will store it in our user move. Once we are stored, we will request a random number. We will use modulus operator to like break that random number which we got into these either of these three numbers, and we will store the computer moves in this variable, and we will check certain conditions. Okay, like whether user put rock and like if user put rock and computer put paper, like then the computer is the winner because rock and paper, the paper is the winner, and paper and scissor, the scissor is the winner. That kind of conditions we will use in our if conditions, and after that we will store the winner in this. Okay, so let us create a function named we will make move. Okay, make move, and we will take an event 256 underscore move, and this will be public, and what we'll do is we will store the user move equals underscore move. Okay, and after that we will call the coordinator requesting coordinator dot, there is a particular function which we can use to like request our random numbers. Okay, so request random words. As you can see, request random words is here. Request random words. What all this will take? First of all, it takes key hash. So you don't have to worry about key hash. Like it will be there in our this link, which will be provided in the description. You just have to come here. As you can see, there is a key hash. You just have to click on copy and paste it as our first parameter. And after that, the second parameter is subscription ID, and we will pass our subscription ID over here, which is over here. Okay, we will pass our subscription ID, and after that we will pass minimum request confirmations. This is like how many blocks you have to wait. Okay, and we will provide like minimum is 3, maximum is 100 or so. You just have to provide like minimum as possible. Like you can provide in your own way, like whatever you prefer. In this case, like for time being, I'm providing 3 block confirmations. Okay, and after that we will have to pass callback, like callback gas limit, how many like gas limit we want to provide. We will see like why it's used and number of words which in it. Okay, so callback gas limit we will provide 2 lakh, and it's 2 lakh, and we will need only a single number. Okay, and okay, we'll have to make this event 64 because subscription IDs are two small numbers. Yeah, this is how it works, and we'll have to make this as 64 as well. Okay, so this is subscription ID, and we have requested it. There is a return type over here in our request random words. It is request ID. Okay, so why it's used? Request ID is used like if there are multiple users in your application, in your Solidity application, you will use request ID to track the requests of users. Okay, you will have mapping like address to a event 256, uh, like there will be a request ID for each request you make. Like for each user, you will get a request ID. It's like request underscore ID. You can assign it like this, and with a event 256. Okay, like particular like you can like see or map to see whose request is this, like which user's request is this. Okay, for now, as we are only a single user of this application, we will be having we will not be using that request ID for now. Okay, we will just skip that part. We will not be using it. And once this function is being called, right, what happens is, as you can see, this subscription, what we do now, we are here. Okay, once it's called, VRF coordinator come into play, and after that VRF service and everything happens. VRF coordinator will call consuming contract with the function fulfill random words. First of all, we will call request random words. It will call fulfill random words of our contract. So as you can see, it will call this function. This gas callback limit is what is here, right? Like it is used to specify how many gas which you want to specify so that this function can be run. Okay, like it's like how many gas which you want to provide to like run this function. We will provide 2 lakh to run this function, 2 lakh gas. Okay, and this is how it works. It will call fulfill random words. So now what we will do is we will take our random number. Okay, first of all, we will store our random number in a variable like random number equals numbers of 0. Because we are only requesting a single word, we will use numbers of 0. Okay, like we are only using single one, it will be stored in the 0 position, zeroth index. Okay, zeroth index, as it's an array. So after that we will check. So if the okay, first of all we will like store the computer move. Okay, let's store computer move equals random number modulus 3. So what modulus 3 does is like if you do 3 divided by 3, it will be 3 it will be 1. Okay, if you do 3 modulus 3, it will return the remainder. 3 modulus 3 will be 0. Okay, if you do like 3 modulus 9 or 9 modulus 3, as 3 completely divides 9, 9 by 3 is 3, there will not be any reminder, so it will provide 0. If you provide like 7 modulus 3, 3 into 2 6, 1 will be the reminder. So in this case 1. Okay, this is how modulus works. If you do divide a modulus 3, right, at max, the reminder will be either 0 or 1 or 2. It cannot be 3, because if it's a 3, it will completely divide it. Okay, this is how the modulus works. Like it will return the reminder of this thing. If we'll divide it modulus it by 3, we will get the reminder. So computer's move will be either this or this or this. Only these three options will be there. Okay. So after that we will check. Okay. If user move equals to computer move, meaning that both the user and the computer have done the same move. Like computer also used rock and user also used rock. There is like no winning situation. So what we will do is like winner equals draw. We have to specify this, like both done the same move, so we can't do anything over here. So after that we will have some if conditions, like if the user move is a rock and the computer move is let's say Caesar. So in this case, the rock and Caesar, between rock and Caesar, the winner will be the rock. Okay, so winner equals user. So in this case, user. Okay, so winner will be user in this case. If not, else if condition we'll have to specify, like if the user made the move of rock and the computer made the move of paper. Computer made the move of paper. In this case, rock and paper, we will have the like paper as the winner, in the sense computer as the winner. So we will specify this over here. Winner will be computer. Okay. So after that, like user done rock, and next condition is we will specify like check. We will check if the user move is paper. User move is paper and computer move is rock. Computer move is rock, paper and rock. Paper moves, like paper wins. In this case, the user will be the winner. And after that, we will check if the user move is paper and the computer move is scissor. Okay, scissor. In this case, the computer wins, because paper and scissor, the computer wins. In the sense, the scissor wins. Okay. So now we will check for computer's case. So what else is remaining? Like we have rock and scissor, rock and paper, paper and rock, paper and scissor. In this case, like a scissor is remaining. So user move is scissor and computer move is paper. In this case, the scissor wins, in the sense the user wins. Okay. And after that, we will have scissor again, and the computer move will be rock in this case. So now the computer will win, because rock and scissor, the computer wins. Okay, this is how it exactly works. And these are all the conditions. Like you can just pause the video and go through this condition one by one yourself, so that you get to know like how exactly it works. So let us see what's the error. So it says the visibility differs. So I think that we can like make it internal, because it's specified there as internal itself. And after that, there is a event to 6, which is specified. Okay, as I said, like you can use request ID to like use mappings from the users to request IDs, so that you like keep track of mappings of different users uniquely. So in this case, as I said before, like we are only the single user. In this case, we don't need request IDs. Okay, so we are not going to use it for now. And this is how it works. I think most of the part is done, and we don't need anything else. There is a single warning which we can ignore for now, and everything is fine. So now let us deploy our contract. So in this case, we will deploy our contract to Sepolia testnet. We will select Sepolia, we'll use MetaMask, and my like provider will be like connected over here. I will get the VRF coordinator address will be here. You can see the VRF coordinator is here, copy it, and I will paste it here, and subscription ID. So first of all, we will have to create subscription. As you can see, we need subscription ID here. So what we will do is we will create a subscription. We'll click on create subscription. We will connect our wallet. Like we will connect it as I connected before. It's directly connected. For you, it might ask for confirmation. Okay. And after that, you are like these are the option, and admin address is our wallet address. You can't change it over here. Okay. And after that, we will click on create subscription. We will have to like make a confirmation transaction as well. Okay. So here we will confirm it. It will be done within 12 seconds. So after that, we will like once this confirmation everything is done, right? We will get a subscription ID of our own over here, which we can pass in, which will be stored here, and using it we can like request random words over here. Okay, if you have any single questions with regarding to this game, or if you have any suggestions regarding this video, like whether how the video can be improved based on your suggestions. Okay, it will be very helpful for me to improve this video to provide a quality content. Okay, and make sure to subscribe to this channel. Okay, like I'll provide most such crash courses, more on the Chainlink series itself. Like we will like complete the Chainlink series functions. Okay, every functions will be covered by us. Make sure to subscribe. So hopefully our subscription is created. We'll have to add some funds, as I have said before. So as you can see, I have 94 link. You might have the link as well. Like you just have to click on here, and you will have to connect your wallet and log in via GitHub, and you will have to click on send request. You will get 25 test link tokens. Okay. As I already claimed, I can't claim twice in a day. You can just come over here. The link will be in the description. It is faucets.chain.link. Okay. So now let us add some funds. After you have got some funds, you just have to come here. I'll click on. We will have 10. Okay, I'll provide 10 link tokens. Click on add funds. I will have to approve the funds over here, so that like it will use that funds to store. We will confirm. It will take 12 seconds as well, and we'll get our confirmation over here. As you can see, you just have to provide over. You can even get the testnet tokens as well. And this link, which is of Excallidraw, will also be in the description. You can come over here and like, if anything is confusing to you, you can come over here and refer to video by rewinding. You can get to know it clearly. Okay. So this is how it works. Hopefully our confirmation is added. So yeah, our funds are added. We will have to click on like add consumers. So for now, we don't have any consumers. So like we didn't deploy our contract. So what we will do is we will click on I'll do it later. Our subscription will be here. As you can see, our subscription ID is 8244. You don't have to worry for why what if this is shared. Like even if it is shared, there is no worries. Okay, like you will have to add consumers, right? Because you will have to add consumers. Even if someone else uses, their request will not be fulfilled, because like they will not be the consumers of this subscription. Okay, I will copy it. I will paste it over here, and I will have to get the coordinator address as well, which should be in. I will duplicate this for now. Duplicate this. I will go back. I will copy the VRF coordinator address from here. I will paste it over here. Okay. I click on transact. Our transaction will be done. So I will show over here. I'll have to confirm it, so that our contract is being deployed. Over here I'll confirm. So if you didn't watch the previous video, which we had a crash course on Chainlink CCIP, you should definitely check that out, because like it is the most wanted technology in this space because of interoperability, if you know it possibly. Okay, like you can know that complete details of all those things. The link will be in the description. You just have to click it and increase your knowledge. That's all. Okay, so our contract is deployed. So now let us make a move. Before that, we will have to add our consumer to our subscription. So let us click on add consumers. We will add our consumer address over here. I just have copied it from here. You have to click on copy it over here, and it will be added over here. As you can see, FC1 is here. I'll click on add consumer. I'll have to approve the consumer to be added. Okay. So I'll click on add consumer, click on confirm. It will take some 12 seconds like for confirmation. And let us make a move. Okay, so in this case I will take rock, or okay, I will use rock to move. Okay, no, I will use paper in this case. No, I will use scissors. Okay, I will use scissors. I will provide 2 as my move, because 2 represents scissors. So hopefully our confirmation is done. Consumer added. Yeah. Once our consumer is added, it will be shown here. So we will click on transact. Okay. So our transaction will come over here. We will have to confirm it. And over here, just confirm. So what it will happen is, as I've said before, this will call this function with the data which we have passed here, and it will wait for 3 block confirmations. Even it will take like more time than just 3 blocks. Okay, it will take too much time, like in the sense it have to generate random numbers from the Oracle network, right? Like it will take some bit of more time, and after that it will call this function. Okay, you can like completely monitor it how it's going and all over here. So I will just refresh this page. So I will know like if there is any, yeah, as you can see, if there is any requests over here. I have created a request just before 23 seconds, as you can see over here. So once this is fulfilled, I'll come back. I'll speed up this video so that your time is not being wasted. So as you can see, my transaction is successful in the sense we have successfully like requested a random words from the VRF, and it took around 0.6 links to confirm, like to make our transaction. Okay, make our transaction in the sense it will have to call our fulfill random words function, right? It took this much amount of link. Okay, so we'll come over here. First of all, we will see what the computer's move was. Okay, computer's move was 0. In the sense, the computer made a rock move and we made it like 2. In the sense, we will see where is scissor move. Yeah, we made 2 in the sense we made a scissor move and computer made a rock move. Okay, as you can see, as you like already guessed it, rock and scissor, the rock wins. If you see the computer, if you see the winner, where is the winner? Yeah, here. As you can see, the computer is the winner. So as you can see, this is a complete implementation, though it's a basic one. It's a complete implementation, okay, so that you get to know like clearly, so how exactly it works and all those things, okay. So I hope this video was helpful in learning something new that you never knew before. And if the video was helpful, make sure to like the video and subscribe to the channel for more such Chainlink courses. We are coming with more for now. So let's meet in the next video. Till then, take care. Bye bye.